So now we've got our report. The first thing we want to do is just open up the report view a little bit bigger. There we go. Alright, the first page of the report is basically just the introduction, your cover page. The second one contains your client information, some site information, and then your weather data, so temperature and rainfall, which is quite useful, especially for smart grid systems where you want to try and match your consumption to certain seasons. Alright, third page, we'll be looking at the consumption breakdown and suggestions. Again, we can see the efficiencies that we applied, and that has dropped our daily kilowatt hours from 42.5 to about 16 kilowatt hours. The next page is the system savings and cash flow. We'll come back to that later on. Okay, the first graph we want to look at that's of interest is basically our annual energy projection. So that tells us how much energy are we using still and how much energy is being generated from the solar panels and what is our losses. So the red portion at the bottom is electricity shortfall. That's what we're going to be basically buying in on a monthly basis from our utility. The PV utilization, that is obviously direct PV generation, and the blue line at the top, or the blue bar at the top, that is surplus throttle. That is our throttling losses. The energy consumption, the old energy consumption, used to be the green plus the red, so we get an idea of what portion of our energy bill we're saving by looking at the green plus the red. So you can see the green, which portion that is. Alright, so the next graph of interest is our annual cost projection. So you can see the current cost, which is the old cost, the cost right now before the PV system and before the efficiencies. The second one is the post efficiency cost. You'll see the biggest drop is obviously there, and then in this case the post PV system cost is only a small drop from the post efficiency cost, and that's the green line. Over here, these are in your smart grid design phase. These three graphs are probably your most important to help you design orientation, angle, and all of those things, a number of panels, etc. So here we can see whether our generation is actually a match for our consumption. In this case, we're not a match at all. I don't believe that changing the panels to east or west, if we can find a east facing roof or a west facing roof, in this case it's not going to make much of a difference. So we can't find a profile where every day in the afternoon we're just missing it. If you look at it, the evening consumption, or the consumption seems to be more towards the evening, and facing it west isn't going to help us much, even in Cape Town. I think the consumption is too late in the day. Alright, in the case where you see there's a big difference, if we look at the generation, our generation in summer, we can see a nice profile almost hitting 1.5 kilowatt. In winter we barely hop over 1 kilowatt, and that's because of our sun angle. In summer in the Cape area, the sun would be about 80 degrees above the horizon. That's the max solar elevation for the day, and in winter it's sitting 34 degrees above the horizon. So if we can find maybe a steeper roof, and if we want to generate more during the winter time, if we can find a steeper roof or something, and we can pitch our panels at a bigger angle and a higher elevation, then obviously we'll generate more during the winter. The other alternative is, if we want to generate more in the winter, is just to add more solar panels, but that means we can have more throttling losses. We've already added 2 extra panels, and you'll see a large amount of throttling losses. So I don't know if adding more panels is gonna bring our overall payback down. I don't believe it is. The next thing to look at is your smart grid system specifications. So the first thing is the technical specifications of the system. So we can see the PV array, the rated capacity inverter size, whether we've got monitoring in there or not, and then the second batch of info is the site specific info. Okay, so we can see it's a 4.42 year payback, and I'm pretty sure that's almost just because of the efficiencies. The PV system I don't think is contributing to that quite a lot. Okay, so we can see what our daytime consumption is. That is why our PV generation, we have so much throttling losses, because very little of our consumption is actually happening in the daytime. Okay, potential daily generation. So we've got the system could produce 8.1 kilowatt hour per day, but it's only going to do about 5 kilowatt hours per day, and that's because of the throttling losses. Okay, the specific yield including throttling losses, 3.8 kilowatt hour is our specific yield, and inverter max generation is 1.5 kilowatt, inverter load factor 49%, and that is because, if you remember correctly, we had to bump the inverter up by 1. So instead of getting the small Fronius Galva 1.5, which would have been the correct option here, we said let's bump the inverter by 1, so we got a 3 kilowatt, which is the next size up in the Fronius range. So we got a Fronius Primo 3, 6 panels is what we selected, and the rest of the equipment, and we also have a City of Cape Town certificate, COCT certificate, which means we've got to register the system. Alright, the total ex-VAT, the total including VAT, those are the amounts that with the margin slide on 0 that we're looking at, that should be recommended retail for this type of system. When we want to send this to a client, we click on the PDF exporter, we select our image quality. In this case, let's use medium, so it'll just be a little bit smaller and more ideal for emailing, and we say OK. So once we're done with that, we select a name for our system and we hit save. It's as simple as that. You should be able to then just basically mail the report through to the customer as is. You don't need to edit or change anything on there.